Good evening, all of you.
Good evening.
Good evening, sir.
Good evening, sir.
Sorry for the delay. There was a meeting and I had to wait till it is over. One second, wait, let the board dry. Okay. No, we are discussing first assignment 1 or assignment 2.
Both.
So 1 and 2.
Assignment 1. So, 43, 45,
37.
37,
So 40
So 48.
48, 40,
and 46 also.
46.
So 31.
27.
45.
11.
Hey, first 30 we have already done. अब फिर से 11 कहाँ से ले आते हो यार? First 30 we have done, right?
Yes.
Yes, sir.
Yes.
So,
So 39. 7 and 42. Okay,
49.
42.
49.
36.
One second, let me open this assignment 1. I don't have a hard copy of this. I'll have to open it on the system. Eleventh ka answer is not matching. Is that your only problem?
So we
11,
have to calculate epsilon r, right?
right?
Okay, yeah, then it's. I mean, I didn't ask this down.
Okay. 11th we have already discussed in the last class. Answer is not matching. Get it rectified. 31.
So in this question, if we assume a positively charged wire, we get A. If we assume a negatively charged wire, we get B. So then what should we do?
Infinite line of charge lambda per unit length. They didn't say minus lambda, right? They said lambda.
Oh, okay. Okay.
So take positive one.
Yeah.
31, is that the only doubt?
So but the answer is given B.
Let's see. You
So
have
can you solve it?
positively charged body. Right. Where am I? 31. Now work done in moving a charge Q from A0. Infinite wire, infinite wire. From A to A. Am I right? A to A. Delta V is minus integral E dot dr. Minus integral E is 2k lambda by r dr. You are going from A to A. Multiply this with Q to get the work done. Minus 2k lambda Q integral dr by r, directly I'll put ln of r, which will be 2a by a, but with a negative sign. 2k lambda Q ln of 1 by 2.
Okay, yes, sir. I must have forgotten the minus sign. Done.
36. 36. 1 second. No, yeah. Right. Now, you have a dipole moment this way. This is the dipole moment minus Q to Q. It remains in equilibrium.
Yes,
Right?
sir.
Mu is given. So this is mg. This is friction, which you take as mu n, and this will be the normal force. Now, torque due to the dipole and the electric field is torque due to couple. Torque due to couple's biggest advantage is you can take the torque about any axis. Right? If I take the torque about this axis, friction will not produce any torque, normal force will not produce any torque. P cross E should be equal to the torque due to mg. mg into this perpendicular distance. I will call it R, which I'm damn sure you'll be able to calculate. Take the torque
Yes,
about
sir.
this particular point. P cross E, about which axis have you taken its torque due to a couple? About any axis it is the same. Right? Or take about the center. If you don't want to do it this way, you can take about the center. P cross E should be equal to frictional force into R. Friction will be mu n. Reason being, this is the equilibrium due to torque, right? Equilibrium due to forces, mu n should be equal to mg sin theta. N will be equal to mg cos theta. Will you not take the electrostatic forces? Uniform electric field में force on a dipole is zero. Uniform electric field में force on a dipole is zero. Torque is not zero. So if I am taking about the center of mass, then mu n is equal to mg sin theta, n is mg cos theta. P cross E is equal to F into R. If somebody is keen on taking the torque about center of mass, you can solve it this way. If not, you can take the torque even about point of contact. Can I rub the board?
Yes, sir.
$37. P is technically P I cap, right? Electric field is 4xy square I cap plus 4x square y j cap, right? Find the force on the dipole. Minus P dot E. P dot E may, it will become 4xy square P. I dot I with a negative sign. I dot J will become 0. This is the potential energy. F is equal to minus of I cap del U by del X plus J cap del U by del Y. right? Del u by del x plus j cap del u by del y. Differentiate this with respect to minus of I cap. When you are differentiating with respect to x, 4y square p I cap plus differentiate with respect to y, it will become 8x p j cap with the negative sign. Remove this, this becomes negative, this becomes negative, this should be the force on it. You take 4p common, 4p common. You will get with a negative sign y square I cap plus 8x j cap. If you take 4p common. What is the answer given for this?
So it is the answer is 4py and in brackets y square plus 4x square ka root.
So because
Okay.
it's perpendicular, so they just squared and
He
rooted.
took the magnitude of this.
So,
You
so
wanted
wouldn't
to-
it be minus 8xy partial
Tell me
differentiation?
something. Minus 8xy, he's right. Differentiation may minus, when I'm differentiating this with respect to y, minus 8xy. Now, magnitude of this will be root over of 4py square whole square plus 8pxy whole square. Simplify this and see if you are getting the answer.
Yes, sir.
We reported in vector form, they wanted the magnitude. That's okay. Keep seeing the options as to what they want.
Done, sir.
Board is getting very dirty. I have to either change the board or shift to this electronic. Fine. Now, next is 39.
So in this, there's no point P.
39. Consider the situation of the figure of work done in taking a point charge from P to A. P is C. This is A, this is something, this is Q, this is B, this is C. Is WA. From P to B is WB, and from P to C is WC. You don't need the point P here. That's the beauty in the problem. A, B, and C are equipotential. Do you agree
Yes,
with
sir. I
that?
understand. Yeah. Okay.
Now, P
Potential.
will be at the same potential for all the three problems because P is the same point. So potential difference from P to A, P to B, P to C will be the same.
Yes.
So work done will be equal.
Yes, sir.
Question number 40. A charged dust particle of radius moving in a horizontal electric field of intensity thus. The surrounding medium is air with coefficient of viscosity thus. If this particle is moving with uniform horizontal speed, number of excess electrons on the drop are 6k. Find the value of k. Charged dust particle of radius is moving in a horizontal electric field of intensity thus. Surrounding medium is air with coefficient of friction. Mass of the dust particle is given No. Mass of the dust particle is not given, right? So then he wants us to take only electric field and viscous drag force. Q into E should be 6 pi eta RV. Stokes theorem, it's taught to you people.
Yes, sir.
6 pi eta RV. Who is that? No. कौन सा बैट में नहीं हुआ?
फ्लैगशिप 2 में नहीं हुआ.
Okay. Temporarily remember this formula. You did this either way in your 10th standard. Corona batch, you did in your 10th standard 6 pi eta RV. Dimensionally you verified this. Viscosity, ICSE board, मैंने देखा है textbook में सब. 6 pi eta RV.
भूल गए.
Fine. Anyway, this is the force on a spherical body due to viscous drag force. This is called Stokes theorem. Stokes theorem. Temporarily, besides that question, make a note of it and keep it. Once that is done in fluids, you equate these both forces because he says it is moving with uniform velocity or what? Uniform horizontal speed bol raha hai, velocity bhi de diya. Uniform horizontal speed. So these both forces should be equal. You will get Q, from Q you will get the value of K.
So can you repeat what 6 pi eta RV is? Force on?
Viscous drag force on the particle.
Okay.
Viscous drag force on the particle. Hey, cheating कर रहे हो आप लोग. Millikan soil drop experiment किया है अपनी chemistry में?
नहीं, हाँ किया है.
Yes, sir. No, sir.
मारने का मन करना है. उसमें किया है आप लोगों ने. That particle is falling down. Mg is equated to Eq. This is equated to buoyancy plus 6 pi eta RV.
सर हमने सिर्फ mg इक्वल टू eq ही किया होता है.
यस सर, हमने
उसके
P
अलावा
और स्टोक्स नहीं लगाया था.
ओके, तो माफ कर दो तो अब लगा. Now 42 का आंसर doesn't match. It's wrong. I think 2 or 1 कुछ difference है. हाँ, 2. 42 is quite easy. This will be this positive charge. So 2k lambda by r. Here this will be k lambda by r, and this will be k lambda by r. This is 2. Sorry, this is positive charge, right? This will be k lambda by r. So net total I will be left with this minus this. Lambda 1, lambda 2. I took both lambdas same. Which is lambda 1? This is lambda 1. This is lambda 1, lambda 1, lambda 2. Semicircular ring ka, this is the field. The semi-infinite wire ka, this is the field. अब जो ratio चाहिए उनको x axis y axis. अब कुछ answer 1 दिया हुआ, you people will get 2. Am I right?
Yes, so the answer is 2 only. We discussed this last time.
Okay. Can I rub the board? Yeah. 43. You have negative charge here, positive charge here. This is a problem designed for the sake of problem, right? You have an electric field established here. There will be friction because of the electric field. See, force on this and this will be equal and opposite. So only friction produces MA. Acceleration for center of mass, only friction produces. EQ on the positive and negative will cancel out. Right? Second point. Translational dynamic ho gaya. Abhi take theta, this will be d theta. Force on this will be E dq. Similarly, force on this will be E dq. Right? So torque due to the electrostatic forces is E. dq is lambda r d theta. dq is lambda r d theta. Agreed? Into r sine theta, this into 2. E dq. dq is lambda r d theta into r sine theta. Integral of this. Least value of theta is 0, maximum value of theta is pi by 2. This is clockwise. Minus f into r is anti-clockwise, equated to I into alpha. I is moment of inertia of the ring, mr square. This is my second equation. Third equation, A equal to R alpha. This is called the condition for
Rolling.
Rolling.
three equations, three variables. Don't integrate FR in this. The integration is over here. E dq. dq is lambda R d theta into R sine theta into 2. You understand why we multiplied with 2. This is torque due to a couple.
So since that quarter is uniformly charged, can we assume it at the center of mass and take the charges?
Don't, because the concept of center of mass don't exist for charges except for shielding में for hollow sphere and solid sphere. छोड़ के semicircular ring आप ले लिया, center of mass apply करके देखो, answer will not match.
That wasn't matching. That's why I was just wondering why it's
No, concept of center of mass don't exist for center of charge. You'll be taking a risk. Question number 45. 45. Et is being given as something E naught sine omega t. Am I right? E naught is given, omega is given. What else do you need? Charge is given, mass of the particle is given. Q into E will be Q into E naught sine omega t will be equal to net total force M into dV by dt. Aha. Yes or no?
Yes.
Force is equal to mass into acceleration. Put dV is equal to Q E naught by M sine of omega t dt. Integrate this, will I get velocity?
Yes.
Yes.
Right, plus some constant C. Integrate from 0 to 0 at time t, find out the velocity. होगा आपसे?
Yes.
Once I get velocity is telling you, then the maximum speed attained by the particle at subsequent times is. Once I get velocity dE by dt, I can equate to 0. That I will get the time at which dV by dt is 0. That means time at which velocity is maximum. That time you substitute in the expression for velocity. Will I get the maximum velocity?
Yes.
46, I sent you people the correction. Without the correction, you will not be able to do. And with the correction, the question doesn't make sense. It is just equating two fields. Particle is in equilibrium means field due to inner ring and field due to outer ring should be equal and opposite there. Can I rub the board? Am I disconnected?
No, sir.
No.
sir.
No, sir. No, sir.
Forty-six. As I already told you, field due to both the rings should be equal and opposite. You know the expression for the fields. With the value given there, you will not get the answer. There was some correction in that answer, which question which I sent to you people. The charge minus 2 by 5 to the power 3 by 2 into q. Q doesn't come in the numerator. Right? Field due to both the rings at that point should be equal and opposite. Field due to both the rings at this point should be equal and opposite. If I take QA and QB, the field due to both, you know what is the expression for field, right? This is RA, this is RB, RB, or what am I taking? A and B, जो भी है. Field due to both should be equal and opposite. Field due to ring expression पता है आपको. Substitute. That's all. Right?
Yes, sir.
Did I send you people the correction in the 46th question?
Yes.
Yes,
Yes.
sir.
Use the correction, if not, you will not be able to solve. 48. Two identical small equal charged balls are suspended from long thread secured at one point. The charge and mass of the balls are such that they are in equilibrium when the distance between them is A. L is much greater than A. One of the ball is then discharged. No. See, once you have discharged, now this is L, this distance is A, if I am right. One of the ball is discharged, then this will come in contact with this. You have some charge Q on it, or is that value of Q given? No, some charge Q. Right?
Yes.
One of the ball is discharged. Now have a look at it. P cos theta. P cos theta. I take this to be theta. T cos theta will be equal to mg. T sin theta will be equal to Fe. What is Fe? Q by A square. A or A by 2. Have a look at it. A is the distance between the two masses, right? Yeah.
Yes.
Yeah, distance between the two masses. So your equation is T cos theta is equal to mg. T sin theta is equal to Fe. K Q square by A square. Now what he did is he discharged this and he got this in touch with this. When you discharge this is neutral. If this is neutral, there will be no repulsion. It will come in contact with this. If it comes in contact with this, what happens? Now this will become Q by 2, this will become Q by 2. Now this distance he gives us some value called B. Once again, T cos theta is equal to mg. Now I write T cos theta is equal to mg and T sin theta is equal to K Q by 2 whole square by B square. Now he gave some approximation. L is much greater than A. That means theta is small. Do apply the approximation theta is small in both. In the last step, you get A cube by B cube.
So why does it become q by 2 and q by 2 on
This
contact?
comes in contact with this. Two identical bodies, when they come in contact, this has Q. Both are identical bodies. So they will acquire Q by 2 and Q by 2. If
Okay.
they were not identical, then they will split the charge in the ratio of their capacitance. But what is capacitance will be taught to you in the next chapter. So right now they gave you only identical bodies.
Okay.
Yes, sir.
49 projectile motion है यार. Projected with an initial velocity angle 45 degree. Electric field is upwards. Plates sufficiently long. Separation 2 centimeters. Maximum value of velocity of the particle not to hit the. Oh. H maximum of projectile motion here should be less than or equal to 2. That's it. Electron. So it will experience a force opposite to the direction of the field. Right? So you have got two plates this way. This should be the projectile motion. H maximum of the projectile should be less than 2 centimeters. As simple as it. How do you want me to calculate H maximum here? There are two G's. One is acceleration due to gravity, the other is EQ by M. E rather, electric field. Electric field is nothing but G. EQ by M. Right? So, H maximum का formula क्या है? U square sin square theta by 2G. In the place of G, I will write G plus EQ by M. Because EQ force is in the downward direction. Effective G is G plus EQ by M. H maximum should be less than 2 centimeters is my equation. Yes or no?
Yes.
So just wanted to confirm 47th में सिर्फ वो work done is equal to 0 करके energy conserve करना है ना 47th वाला if you can just read.
एक सेकंड खोलना पड़ेगा यार मुझे फिर से 47 क्वेश्चन क्या है बता.
Sir, I solved it. I just wanted to confirm. A rod AB of length L and mass M is uniformly charged with a charge Q and is suspended from end A as shown. उसमें ठीक है.
Right. Now उसमें एक और काम कर सकते हो. If the rod is uniformly charged, rod के लिए apply होगा. जिस तरह mg or applying at the center, EQ also apply at the center of mass of the rod, you'll get the answer. सिर्फ थिन रॉड के लिए अप्लाई करो, हर चीज के लिए सेंटर ऑफ मास का कॉन्सेप्ट अप्लाई मत करो. थिन रॉड वो भी चार्ज यूनिफॉर्मली डिस्ट्रीब्यूटेड. आप छोटा सा एलिमेंट लेके इंटीग्रेट करोगे तो भी इट विल बी एज द होल ऑफ द फोर्स अपीयर्स एट सेंटर ऑफ द रॉड. EQ you can take it at the center of the rod. आई बात समझ में?
तो वैसा ही कुछ किया है मैंने. EQ और mg को इक्वेट कर दिया है. EQ L/2 and mg L/2 दूसरा आ गया.
Only for this problem EQ you can take at the center of the rod. Do not do it for any other problem. Take a small element and integrate.
Okay. Thank you.
Sir, if we integrate, we get the same thing, like
100% will get. That is the safest. And if ever they give such a problem, believe me, they will not give you uniform charge distribution, because the purpose of giving that problem is making you integrate that function. So giving you uniform charge distribution, you are given the benefit of assuming the charge at its center of mass. For a thin rod, it works.
इसमें तो बिना इंटीग्रेट करके कर सकते हैं. इसमें तो इंटीग्रेट करने का जरूरत नहीं है.
सेफ साइड इंटीग्रेट ही करो. Assignment 2.
Sir, 1.
हार्ड कॉपी है मेरा पास. 1 से शुरू कर रहा हूँ. अच्छा शुरुआत किया है आप लोगों ने. हाँ, रात को सोने का नहीं आज. 1 से शुरू हुआ मतलब लास्ट तक करवाएंगे. वेरी गुड.
So how can a ring have a dipole moment?
Consider an element like this. This is dq positive, that is dq negative. What will be the direction of the dipole moment? Negative to positive. I'll call this dp. So dp I will get as dq into this distance. You are taking this angle as theta. So what will this distance be? R cos theta. R cos theta 2 times. Because this is R cos theta, this is R cos theta. What is a dipole? Minus q cube. Dipole moment is that into the distance between them. Am I right?
Yes, sir.
More orthodoxly, I will put minus I cap to show you the direction. Integrate this theta, right? dq I will substitute as lambda r d. Of limits, I will leave it to your fine discretion.
Sir, here we can't assume the charge at 2r by pi distance and then.
No, center of mass concept will not apply to this. I've been telling you.
Sir, I had a different method for this. So I assumed a dipole of the diameter form. Like
This
of
boy's
that.
voice is from Dadar flagship patch. Second bench में बैठता है. सही बोला कि नहीं?
Ha, sir. Yes, sir. Second,
good.
third one. Sir, I assumed the diameter of the dipole and then I did something similar to this only. Did I get the answer by fluke or is that correct?
What you must have done is you took an element here and here.
Yes, sir. Yes, sir.
इस procedure में क्या होता है कि length of the dipole is fixed but not the direction. अब यहाँ length is not fixed. Length I am getting in terms of theta. So what you will do is you will take a dipole like this, resolve all the dipoles in this direction and add them. You will
Yes,
get
sir.
the answer.
Yes, I did that
Absolutely
one.
no issue.
So it's the
Right.
same thing only, right?
Right, it is the same thing. Old wine in new bottle. Now listen to the second question. You are asking me some potential here. Let me assume this distance is r by 2. भाई साहब potential पूछ रहे हो आप. यहाँ पर negative charge है, यहाँ पर positive charge है, and that symmetric distribution. Positive or negative symmetrically distributed potential will be 0. Yes, or no? Along this axis, even at the center, negative will give me one potential, positive will give me one potential. Along this axis all through, negative, positive are at the same distance. I take any element here, the distance will be this. An identical element with the same distance will come over here. So net potential at this point will be 0. Do you all agree with that?
Yes. Yes.
Now, field बोलोगे तो ध्यान से सुनो. Negative charge के वजह से field will be this way towards the board. Positive charge के वजह से field will be radially away.
Yes, sir.
Now, in दोनों का horizontal will cancel out. I mean, vertical will cancel out and horizontal in this direction will add up.
Yes.
Yes.
Answer आ गया कि नहीं? 1, 2, 3 successfully done.
सर 5 और 6 में यही पूछना है कि मतलब गॉसियन सरफेस अज्यूम करके होता है या फिर सिर्फ इंटीग्रेट करके ही करना पड़ता
है? इंटीग्रेट करना ही पड़ेगा.
अच्छा, ओके सर.
So in 1, 2, 3, coincidentally taking at center of mass works. Like it gives the correct answer.
हाँ
for
sir,
all
2r
three
by
points.
pi.
Don't भाई साहब थोड़ा अगर चार्ज डिस्ट्रीब्यूशन चेंज कर दिया बैंड बच जाएगा. इंटीग्रेशन 1 इंटीग्रेशन से करो. 2 and 3 is making a guesswork of directions only. हो कुछ भी कर लो, it makes no difference. 2 and 3 potential value either way you assume whole of the negative charge here, positive charge here. By coincidence you will get the same answer. I assume in that case 4 nobody has a doubt. Is that correct or somebody having a doubt? Very good.
Can you solve the fourth one?
So sweet of you. I was waiting. Fourth question. Have a look. This is the semicircular disc. Consider an elemental ring थोड़ा स्मार्ट वर्क करना पड़ेगा. यहाँ देख लो, you considered an elemental ring. Elemental ring का फील्ड कितना है आपके अनुसार? 2k lambda by, if I take this to be x, it should be x. Am I right?
Yes, sir.
अब lambda को sigma में टर्न करो. कैसा करो तुम यार?
Sir,
You get
dq pi r.
dq is equal to sigma into this area. This is pi r dr. Pi r dr. Yes or no?
Yes, sir.
Now, this dq should be equal to lambda pi r. If I convert it in terms of lambda, it will be lambda into pi r.
Yes, sir.
Right? So lambda is equal to sigma dr. Now this will become 2k. Lambda is sigma dx. Sorry, here I took x, there I am taking. This is dx. So this is dx. I have this bad habit of changing symbols. Please be alert. Pi x dx. So sigma lambda is sigma dx upon x. This will be d. अब उसके
हाँ
बाद
sir,
तो
thank
आपको
you.
आ जाएगा. Integral of this is my answer. Least value is A, maximum value of B. What are the radii given? A and B. Tell me when I can rub the board.
Sir, you can rub the board.
Now, listen to the fifth problem. You have a cone this way. Now see, human bias is the most dangerous of all. When I gave you this assignment, I just covered Gauss law. So many of you by default assumed this is from Gauss law. You are searching for Gaussian surfaces in it. Right? Consider an element at a distance of x of thickness dx. This angle will be theta, this is r. No, let me take the radius to be r, this is capital R. L is the length of this slant height. AB is L given. You don't have a choice in this regard. Have a look at this. X by L is small r by capital R. X by L is small r by capital R.
Yes, sir.
Now what will you take? First calculate dq on this particular element. This will be q divided by pi rl. What is pi rl?
Gauss
Area
surface area of
cross
cone.
Now that into 2 pi x dx. Will I get dq charge on this particular element?
Yes, sir.
Now I want the potential due to this. K dq by x. Potential due to a ring. Potential due to a ring. याद करो, you should take this hypotenuse. If this is x and this is r, potential का expression is kq by root over of r square plus x square. मतलब the slant height is what I should take. Incidentally, here slant height is x. Are we happy about it?
Yes,
So smartness lies in assuming the element. Many of us will take this as x. Problem becomes lengthy. If I take that as x, then in this formula, this hypotenuse should be root over of r square plus x square. You will get the answer by that as well. Nothing wrong. But preferably take this to be x, you will be on the safe side. dq value you know. dq is k. Now pi and pi will go 2x dx by RL. K 2x dx by RL.
Sir, dq is wrong. It will be 2 pi r dx, right? Small r.
Alright. 2 pi small r dr. I committed a mistake.
It will be dx only. R dx.
Yes, sir.
2 pi r, thickness is dx, right?
Yes.
Now eliminate r and bring it in terms of x using this relation. Eliminate r and bring it in terms of x using this relation. Then substitute the dq here and integrate. Will you be able to do?
Yes, sir.
Yes, sir.
Why are you calculating potential? Because he has work done in moving a charge from infinity to this point. If I get the potential of this point into q is my answer. Infinity का potential क्या लोगे यार? Zero. Yes or no?
Yes, sir.
And the limits will be from 0 to L because you are integrating with respect to x. I repeat, eliminate small r from here. Substitute dq and integrate. You will get the answer.
Sir, you may rub.
सर ये वाले प्रॉब्लम में पिछले वाले प्रॉब्लम में r इक्वल टू एल कर देंगे तो बहुत फास्ट हो जाता है क्योंकि l का मतलब दे नहीं रखा ना कुछ ऐसा उस पे
r equal to L कैसे करोगे यार?
नहीं मतलब कर सकते हैं ना
सर क्वेश्चन में गिवन नहीं है इसलिए
हाँ क्वेश्चन में गिवन नहीं है कंस्ट्रेंट कि मतलब l नॉट इक्वल टू r ऐसा कुछ
So you are considering a cone where the radius is equal to L.
हाँ हाँ सर
And the answer is independent of the radius, so we can do that.
हाँ सर
easy
Smart
हो
move.
जाता है
Did others understand what they did?
स्पेशल केस ले लिया जब r
I'll
इक्वल
put
टू
it this way. If you are solving this for a general condition of a cone, it should be true even for one specific condition of the cone. If you are
Yes.
solving this for the general condition of a cone, it should be true even for one specific condition of a cone. So they selected one specific condition of a cone where r is equal to L. Simplification became much easier. Acha idea. Next, sixth question, right? Hemispherical bowl. Consider an element like this. Now this is R, this is theta, this is d theta, this is r d theta. The radius will be r cos theta. This will be r sin theta. What I am interested is in this r minus r sin theta. Why are you interested in this distance? You have been asking me for the potential here. Now this is the ring. जिसके वजह से potential here need to be calculated. The shaded region is the ring. जिसके वजह से you will have to find out the potential here. dV is equal to K dq by C. If this is the ring, this distance is r cos theta. This distance is r minus r sin theta. R minus r sin theta. So this hypotenuse will be root over of r cos theta plus r minus r sin theta whole square. K cube by root over of r square plus x square. R square is the radius of the ring. R square is the radius of the ring. X square is the distance of that point from the center of the ring. Distance of that point from the center of the ring. R minus r sin theta. Is this clear till here with a square root?
Yes, sir. Yes, sir.
Simplification of this. First substitute for dq. dq. How do I substitute? Sigma is given. Sigma into 2 pi r cos theta into r d theta. Is this simplification correct?
Yes.
R square cos square theta plus r square sin square theta minus 2r square sine theta. What have I done? Opened up a minus b whole square. Right? K 1 by 4 pi epsilon naught. Sigma 2 pi r square by 1 by 4 pi epsilon naught. Sigma 2 pi r square by 4 pi epsilon naught. Cos theta d theta. Root over of. Have a look at it. R square cos square theta plus R square sin square theta is R square. R square plus R square is 2R square. Bring 2R square common. This is 1 minus sin theta. Am I right? कुछ तो बोलो.
Yes.
Hope I didn't miss any constant. Sigma 2 pi make this 2. Sigma R square by 2 epsilon naught. R will come out. So this will become R. Right? Root 2. 2 root 2 यहाँ पर लिख दूंगा. 2 root 2. Integral of cos theta d theta. Root over of 1 minus sin theta. Least value of theta is 0. Maximum value of theta is pi by 2. How do you want me to do this integration? Take 1 minus sin theta as t. What is the substitution? 1 minus sin theta you will take as t. T is 1 minus sin theta. dt is equal to minus of cos theta d theta. Will you be able to solve now?
Yes, sir.
Simplification थोड़ा लंबा और गंदा है, but have done it almost till the last. Should not be difficult for you.
Sir.
हाँ.
Sir, actually in the last one, fifth वाले में मुझे doubt था. Like when we assume that R is equal to L, we actually get a plane surface. तो 3D को 2D में बदलना allowed है.
One of the specific cases now here. Hey, wait.
Sir, but it converts the
capital
whole.
R is equal to L.
Converts it into a circle, sir. तो circle बन गया तो allowed है क्या वो? Answer match कर रहा है, but is it a coincidence or is it allowed?
कैसा हो रहा है यार? R is equal to L अगर है, तो circle कैसा होगी?
सर डिस्क बन रहा है.
हाँ मतलब वही डिस्क.
L slant करो. Slanting length है वो. Hypotenuse.
L is a slant length.
हाँ.
वो भाई साहब R is equal to L. क्या बोल रहे हो? करा रहे हो आप? This L and this L are equal.
हाँ.
That means indirectly.
हाँ, so it is
बीच में जीरो कर रहा है और डिस्क बना दे रहा है इसको.
हाँ, but वो allowed है क्या वही पूछ रहे सर.
One of the specific cases allowed, nothing wrong. All that you have done is taken one case. It appears as though you suppressed it.
So in this, if you take 1 minus sin theta as t square, it becomes even simpler.
Actually, because there is a square root, take 1 minus sin theta as t square, right? 2t dt will be equal to cos theta d theta. Life integration becomes a bit more simple either way.
So can you explain the
square root? The idea by default should strike. That's right. Take t square as 1 minus sin theta.
So can you explain the substitution of dq again?
dq is sigma into surface area of the ring. Surface area of the ring, cut it and make it straight. Length into breadth. Length is 2 pi r. R is the radius of the ring. Radius of the ring is r cos theta.
Okay, so okay.
So can you solve 17th?
6th पे है यार हम लोग. बीच का बाकी छोड़ दूं? I don't mind. So sweet of you.
So can you solve 17 first?
Okay. 17 के बाद ऐसे assignment is over. हाँ.
नहीं सर, शायद से comment out होगा मे बी.
उसका आंसर की wrong है. हाँ सर 17th no.
No. There's some trick in the question. There's some trick in the question.
The maximum separation is when they start moving with the same velocity in the same direction, not when one comes to rest.
हाँ तो वही किया हाँ वही किया था
Nobody spelled the hint.
So then it works.
By the way, 17% तो पढ़ लूं. 17. Two charged particles of opposite sign and magnitude q are projected directly away from each other. Directly away from each other. Opposite sign बोल रहा है, इसका negative ले. With the speed of v, I'll consider this to be where r is the initial distance between the particles. R is the initial distance between the particles. Their masses are m and 2m. Now, how do I know which is m, which is 2m? Opposite sign बोल रहा है. That means you can take anything. Maximum distance between them is nr. Find the value of r. अब सुनो. The only force between them is the internal electrostatic force. That means it is as good as two masses with a spring in between.
Yes, sir.
If it is two masses with a spring in between, because this is negatively charged and there is force of attraction, somewhere down the lane, this will stop and it will start coming back. When Q comes here and it acquires a velocity of v common, Q is here 2m and it acquires a velocity of v common. When will I have the closest or the farthest distance of approach between the two? Neither of them is fixed. If any one of them is fixed, closest and farthest will be when the other particle will come to rest. Here both the particles are moving. Closest or farthest distance of approach is when both of them are moving in the same direction. This distance को क्या बोला उसने? nr. Agreed? Now conserve linear momentum. 2m into v minus m into v is 2m plus m into v common. First equation. Are we okay with this?
Yes, sir.
Yes, sir.
Yes.
Second, conservation of energy. Half mv square plus half 2m v square plus k q minus q by r should be equal to half 3m into v common square plus k q into minus q divided by n. Two equations, two variables. V का कोई गंदा वैल्यू दिया हुआ है, सब्स्टिट्यूट करो, आंसर आएगा.
Sir, I just have a doubt. We are solving this at the instance when 2m particle is about to change its direction to the other side, no?
Why?
Sir, because they have opposite signs.
Because they are opposite signs, this will stop and you will start getting attracted towards the other. अरे भाई, opposite sign will attract, they don't repel. अपने opposite side repel ले लिया. Q and minus Q will attract, they don't repel.
Yes, sir. So that's what I'm saying. After dt time, or the 2m particle will change its direction toward the other side now.
Do you remember I have dealt with this condition in detail where one of the particle comes to rest? याद है कि नहीं आपको? In the complete tabular column, one of the particle comes to rest, A or B. In some situations, neither A or B comes to rest. याद आ रहा है कुछ?
Sir, no, sir. In which chapter have you covered that?
Conservation of momentum.
No, sir, I was not with you in that chapter.
उस conservation of momentum chapter का notes एक बार देख लो, किसी से collect कर. उसमें it's a complete lengthy analysis where between A and B we dealt with all the cases. A comes to rest, B comes to rest, spring comes to natural length, maximum elongation, maximum compression. So those students whom I taught, are you able to recollect this?
Yes, sir.
Yes, sir.
Yes, sir.
All the cases are dealt with. When will one particle come to rest? When will the second particle come to rest? When will the spring come to natural length? When will the spring come to maximum elongation, maximum compression? You have to deal with those, only then you will have an idea. Iska momentum ज़्यादा है, so it will not come to rest, to my knowledge, in this system.
Okay, sir, I'll go through them.
Now, one of the student typed, sir, Coulomb's law is valid for static charges only. Yes, 100% by definition, it is electrostatics. But then why are you applying the laws even when the charges are moving? Because these charges are not moving with relativistic corrections. The speed of the charges is much lesser than the speed of light. So we have the approximation to apply Coulomb's law. But for that, if the charge is accelerating and speeds are comparable to that of light, then Coulomb's law should not be applied.
Okay.
आई बात समझ में?
Yes, sir.
So can you do the 15th one?
So when should we not apply Coulomb's law?
When the particle is moving with speeds comparable to speed of light.
Okay.
Then relativistic corrections will creep in. What did you say? 15th problem. 15th problem का एक टेक्निक बताऊंगा, ध्यान से सुनो. This angle is 60 degrees. I am giving you the hint. I will not solve the complete problem. ध्यान से सुनिए. Do I have your attention?
Yes,
sir. Yes, sir.
Yes, sir.
No, sir. It seems. Who is this? No, sir. नींद में है बंदा. हाँ. Listen. Can you calculate the solid angle? Actually, this assignment may you are supposed to integrate this. But now that you people know solid angle concept, can you calculate the solid angle subtended by this at this point?
Yes.
Yes, sir.
Yes,
Pi
sir.
into 1 minus cos 60.
Pi.
ध्यान से सुनो, I am not writing anything on the board. The hint is being told. Total solid angle subtended by the hemisphere at this particular point is 2 pi.
2 pi.
2 pi. Right?
Yes,
2 pi minus this solid angle. Will I get the solid angle subtended by the remaining part at this point?
Yes.
For 2 pi solid angle, I already know the expression for potential. For this solid angle, compare the expression for potential. I could do this because potential is a scalar. And all charges are at the same distance from that center. Right? Electric potential पूछा हुआ है. पूरा 2 pi solid angle के लिए potential कितना है? KQ by R. Right? Now, all that you need to know is how much is the charge on this. वो charge कैसा मिलेगा आपको? If I know the solid angle subtended by this, भाई साहब पूरा solid angle पता है आपको, solid angle subtended by this area पता है, subtract, I will get this area, right? Will I be able to calculate the charge on this? Charge एक बार आ गया, KQ by R is my potential because every point on the hemisphere is at the same distance from
center.
Is the idea clear?
Yes, sir.
Yes.
I am using the concept of solid angle to calculate the charge on this part of it, this part of the hemisphere. How do you do that? I know the total solid angle. I know the solid angle subtended by this. Subtract, I'll get the solid angle subtended by this. Why do you need that solid angle? To calculate the charge on that sphere, on the leftover part of the sphere. Once I know the charge, K dq by R, because every charge is at the same distance from R. An idea changes your life. अच्छा idea दिया है कि नहीं?
Yes, sir.
Sir, please can I also do the 11th one?
11th is easy. I thought you would ask me the 12th. Instead, you asked the 11th. I'm okay either way. Can I rub the
Yes.
board?
Yes, sir.
Sir, 12th also.
पहले 11th क्यों बोला तुमने?
सर वो किसी और ने बोला।
हाँ?
सर 12th में आंसर मैच नहीं कर रहा.
No, it's matching.
-3, this is 3, right? You want the locus of all the points where the potential is 0. Assume a particular point x, y. Assume a particular point x, y. Agreed? Now, which is -2q? This is plus q, this is -2q, right? Potential here will be k -2q by this distance. What is the distance? What will this distance be? X -3? Hey, yes or no?
Yes.
Yes, sir.
The distance will be x -3. X -3 whole square plus y square. K q by, because of this, what will the distance be? Root over of x plus 3 whole square plus y square. Am I right? This potential should be 0. Now bring this to the left. KQ will get cancelled out. This will be 2 and cross multiply. Root over of x plus 3 whole square plus y square is root over of x minus 3 whole square plus y square. Squaring both sides, simplifying, you will get it in the format given and you will get the answer as x plus 5 whole square plus y square. I have the answer in front of me, so directly I am writing it without doing the simplification. I believe you will be able to do the simplification.
सर तो अल्फा की वैल्यू -5 आ जाती है और बीटा की वैल्यू +-2 आ जाती है, तो उसमें मॉड होगा तभी आंसर मैच करेगा पीछे.
हाँ, naturally मॉड होना है, that is compulsory.
And mod alpha plus mod beta होना चाहिए.
Right, mod alpha plus mod beta will be the right. Accept it.
Sir, in the 8th question, the potential of point Q is not given.
Potential of point Q. Q है कहाँ? अरे चाहिए भी नहीं आपको. तो भाई साहब, you don't need that.
Sir, in this 12th question, sir, we can we do it like we can equate the potentials to both the
Wait, say that
charges?
again. Which question are you talking of?
Sir, 12th. Sir, 12th.
12th.
Sir, can we equate the potentials due to both the charges on x-axis and then
वही तो किया मैंने. You want to do this x-axis separately, y-axis separately. क्या फर्क है? किया तो वही है. आप x component separately simplify करोगे, y component separately. क्यों? This looks a wholesome effect, right? Tell me when I can rub the board.
Sir, can you tell us what we are supposed to do in the 9th question?
I'll come to that. 11th discuss करके 9th को जाऊं.
Yes.
कोई 11th भी बोला हुआ. 9th is coordinate geometry actually. Even this एक कौन सा physics है यार? Isn't this maths? इसमें क्या फिजिक्स यूज कर लिया? पोटेंशियल का एक्सप्रेशन यूज करके जीरो किया है. बाकी सब मैथमेटिक्स ही तो है. Ninth, all the mode is mathematics. Anyway, wait. 11th में 11th, if it is a square like this, you have plus q here, you have minus q here, you have minus q here, you have plus q here, right? So potential at the center will be 0. Mix up q and minus q and q will cancel out. V1 according to them is 0. Now rhombus ka, please do calculate. You know the criteria for rhombus, right? This will be 3L by 5. This will be 4L by 5. This will again be 3L by 5. 4L by 5. This is minus Q. This is Q. Minus Q. This is plus Q. वैसा डिस्टेंस पता है क्यों पता है तो पोटेंशियल यहाँ कैलकुलेट कर पाओगे और डिस्टेंस कैसा पता चला यार तुम्हें दिस होल एंगल इज 74 74 डिवाइडेड बाय 2 कितना है
37.
वंडरफुल एक बार 37 पता है and distance between one L पता है you know L you will be knowing this value similarly you will get this value because of all four of them potential यहाँ V2 calculate कर पाओगे
हाँ सर
I have the answer with me, so I'll write it here. But you will calculate k cube by L, k minus q by whatever it is, k cube by 3L by 5, k minus q by 4L by 5, k cube by 3L by 5, k minus q by 4L by 5. Add them. Nothing to worry about directions because it is potential and it's scalar.
Yes, sir, you can talk.
बोलो किसी ने 9th बोला है if I have heard them right 9th में देख लीजिए what he has given you is pure coordinate geometry. This is y is equal to 2x equation. Yes or no?
Yes, sir.
Say something. At x is 1, 2, 3. 1, comma 2. Field will be in this direction or this direction. This is the field. Slope of the equipotential surface is 2. इसका slope कितना आ रहा है? Slope is 2. Slope of the electric field पूछा हुआ है, they should be perpendicular. M1 M2 is equal to -1. M2 का slope बता पाएंगे आप?
हाँ सर.
Isn't it -half?
Yes, sir.
So among the four options, जिसका भी slope -half है, that's the answer. Pure coordinate geometry. Physics से कुछ लेना देना है.
Sir, so 4 and 8 has nothing to do.
They are making a fool out of you. Just slope of the line. In four options, में जिसका भी slope is -1/2. That's my answer.
Yes, sir, I got stuck at the last step. I calculated the slope.
Can I rub the board?
Yes, sir.
Somebody, Yashvi Mehta type 13, if I'm right. 13.
Yes, sir.
13. Charge on a ring of radius r varies according to this azimuthal angle. Potential पूछा हुआ है. Potential at this particular point, dV k dq by r. K dq is lambda naught cos square phi r d phi divided by r. This will be lambda naught by 4 pi epsilon naught integral cos square phi d phi 0 to 2 pi. That's it. Cos square phi integration कैसा करोगे? Converted into 1 plus cos 2 pi by 2 into d phi. पता है कि नहीं? Cos
Yes,
square
sir.
phi integration.
Sir, can you do the 8th question?
8th question, they have given you a cube. 1, 2, 3. Side row किया मैंने. 1, 2, 3. This is point A. This is point B, point B, point D. This is point. I'm unable to see here.
C.
What is the point? C.
C.
C. This will be at 8 volts. This will be at 5 volts. This will be at 2 volts. Electric field will be from higher potential to lower potential. Technically, always
Yes, sir.
I'm a lazy guy, so I will write 8 minus 2. 8 minus 2 when you write, it will be field into the distance. But negative sign का क्या किया यार तूने? Delta V is minus integral E dot dr.
Yes, sir.
Negative sign का technically I took it to the left. This should be final minus initial. Field is from higher to lower potential. Field lines are like this. Final potential minus initial potential. Very orthodoxly, delta V is minus integral. Delta V is 2 minus E is minus E into the perpendicular distance. कितना है? It will be 0.2 times root. This negative sign is because of it is final minus initial. 2 minus 8. You get the answer from that. I am a lazy guy, so I'll skip the negative sign here as well as the negative sign here on both sides. But technically, you should write the negative sign on both sides. Delta V is V final minus V initial equal to minus integral E dot dr. Does this complete the assignment?
Yes, sir.
Very good. Tomorrow you will receive the assignment on Gauss law. Tomorrow evening. Sham tak.
Oh, yes, sir.
Right?
ठीक है, sir.
Chalo. See you people. Good day.
Bye, sir.
Bye, sir. Thank you.
Thank you, sir. Bye, sir.
I'll send the recording.